Good morning, good afternoon, good evening to everyone, wherever you may be across the world. Thanks so much for joining us here live today for Serverless Office Hours, streaming on AWS and, of course, Serverless Land. My name's Julian Wood, and I'm a Senior Developer Advocate for Serverless at AWS. And this week is Step Functions Week. And I'm joined, first of all, by my colleague, Ben Smith, the Serverless savant of Step Functions. Hello, Ben. How are you?
Hello, mate. Good, thanks. How you doing?
I'm doing very good. It feels rather strange because Ben and I basically live in the UK, and so we're rather close to each other. And all the other hosts and other people, a lot of them are US based, so you get to benefit from the Queen's wisdom. Is that correct?
Yeah, sure.
If you say so.
Yeah.
And I'm also super happy to have a surprise guest. And I did click on the slide annoyingly. And so he's certainly not a mystery. And so welcome today to the famous Dan Ronald, who's a Senior Product Manager for AWS Step Functions. Dan, how are you doing today?
Oh, doing great, thanks. Good to be here today.
Excellent. Well, my silly joke was going to be Dan must be very energetic running up steps for a living. But today, he's going to be our data flow demon, and data flow is something we're going to be talking about during the show. So the normal flow is the first general half-ish of the show. Ben is going to show us some new step functions, cool stuff. And then we open it up to all your questions about step functions or anything serverless in general. Dan is here to answer any questions that myself certainly won't know. And so if you have any questions for the product management part of it, Dan will be super happy to help. And Ben is going to head on to the demo. But just before then, let's just have a look at what other stuff has been going on Serverless Land. Serverless Office Hours carries on every single week. And last week was the turn of AWS Lambda. And James Bezic was showing his Lambda Operators Guide, which is a really great information about how to operate Lambda. And so look at the links at the QR code at the bottom of the screen, and you can look at last week's episode. Then what's new in AWS Serverless? Well, there are 3 or 4 different things that have been coming out over the past week. One of them is AWS Chatbot, and that expands coverage of AWS services through EventBridge. And this is interesting because it means Chatbot customers can receive notifications in chat channels. And these are things like Slack and Amazon Chime. And there are 200 different EventBridge events, and it's just a cool way to connect them together. You can use AWS CloudTrail to log DynamoDB streams, data plane API activities, and that's rather than just the previous control plane activity. And so get records and get shard iterator, these are DynamoDB things, and you can then investigate item level changes in your DynamoDB tables in CloudTrail. NoSQL Workbench for DynamoDB now has CloudFormation support. So, of course, that's super great to be able to manage and modify the data models in your template. And a cool one I thought to also bring up was SNS. Amazon SNS grows a set of message filtering options, which is super useful. And this is a way to have certain SNS messages go to different subscribers. And that offloads some of your filtering logic from your subscribers, as well as your message routing logic from your publisher systems. So that's the kind of things that have been going on in the new releases. And then just looking at some recent AWS compute blog posts, James Bezic is doing an excellent series on operating Lambda, which is part of what the Operators Guide is. And there's a new one. He's starting to look at performance optimization. And that involves cold starts and latency and things about the execution environment lifecycle and some really good graphs about concurrencies. That's super helpful to be able to understand that. And then we have Ben Smith, who we happen to have here today, who's doing a really good series on getting started with serverless. Ben, why don't you just let us know about that?
Sure. So it's a series about how to start building with serverless applications for developers. So you already know how to code. Perhaps you've heard about serverless a little bit, but you've not really tried it out much. And it starts 100 level right from the beginning, not even talking about AWS services from the first post. And it's a series of blog posts, code samples, there's a GitHub repository to sort of guide you through how to build out a serverless application. And at the moment, the first 3 blog posts are already published. It's all about building from your local IDE.
So thank you, Ben. It's a really good series. If you're wondering what this whole serverless thing is about and how different things link together, this is a great place to start and doesn't assume you know too much about AWS and too much about cloud and too much about the Lambda and API gateway and the various things. And then Justin Callison's seen me talking step functions today is about a really good, cool way to control concurrency in distributed systems. Eric Johnson on our team, optimizing service development with SAM config. And then Ben has done a whole blog post on what we're going to be talking about today. So I'm not going to ask him to explain the blog post. Scene, we have the rest of the show to talk about it. Then just to bring up some other things where you can link off, this is James Bezick's Lambda Operators Guide. So yeah, certainly have a look over here. Some great information about operating Lambda. And then a new thing we've recently released over the past few weeks is called the Serverless Patterns Collection. And if you're using infrastructure as code, particularly with our serverless application model or AWS SAM, or even with the CDK, the Cloud Development Kit, these are little super useful snippets of code that you can put into your templates to be able to make life much simpler than rather hunting the interwebs looking for how to tie up API Gateway in AWS Lambda or one of the various other AWS services. So this is a super useful way to be able to just get that code that you want to put into your templates, and they're all deployable via SAM or CDK, and all the code is available on GitHub for you as well. So Ben, I did jump ahead before, but this was the Getting Started with Serverless guide. So here's a link directly to the series. And so yeah, this is I should have probably put the slide up when Ben you were talking about it. Sorry about that. But yeah, this is all getting started with serverless. And the last thing is Serverless Live, which is a whole bunch of us are talking for a full virtual day of technical deep dives and demos and more. And please register. This is on May the 19th from 8 to 1:30 p.m. in Pacific time. And that's going to be streaming on Twitch on this same AWS channel, and that'll be a whole full day full of serverless fun to be able to look at. So that's just all the intro stuff. I think it's time we should hear from Ben.
Thanks, Julian. I love doing live videos with you. I feel like I'm on the radio because your presentation voice is so rich. Okay, you've put my screen up. Thanks very much. So yeah, we're going to be talking about step functions and specifically about input-output path processing and how this new tool called the Data Flow Simulator helps to make that much easier to model how your data looks as it sort of passes through a state in a step function, workflow. But before we jump straight into that new tool, it's probably useful, I would have thought, to have a little recap on what step functions are, which is why I have this beautiful picture up from a previous blog post. So step functions are a way of building out workflows to orchestrate AWS services or other microservices. So for example, this example here is showing how you can build an application that pulls together Lambda functions, DynamoDB tables, Amazon Comprehend, and API Gateway to capture form data, decide whether that form data is positive or negative, save that to a database, and branch with some conditional logic and return the response back to the user. And all this is built with very little code, just 2 small Lambda functions, and the rest of that logic is all held within AWS step functions. So it's a really fantastic tool, which I love talking about, actually, because it's got so many different use cases, and definitely worth having a look at our Serverless LAM website. We have a learning path all about step functions. Perhaps someone can paste that, Julian, into the chat there to the learning path on step functions.
I certainly will do. Just please, if there are any questions that are coming in, please put them in the chat, and we will either respond via chat or I will interrupt Ben and get your questions answered. So here, please don't be shy to ask any questions, and help us help you out with step functions.
So one of the really interesting thing about step functions is that it allows you to persist and maintain state across serverless applications. So we know that serverless applications and serverless services like Lambda, for example, are essentially stateless, or the state only exists for the duration lifecycle of that Lambda function. But if you use step functions and build workflows to orchestrate your Lambda functions, you can actually maintain state for the duration of an application lifecycle. So a step function workflow can actually last for up to 1 year. So you can maintain state in your application for a whole year. And that state is passed from one step or one task or one workflow step to another using JSON. Now, JSON is a kind of semi-structured data type. It's not really relational. It's not quite unstructured. It's something in between. And we have these different controls within a task that allow you to manipulate and organize your JSON data in various ways throughout the life cycle of a step function state. And they're listed here in the order at which they're applied. So you have something called an input path control, the parameter control, you have the result selector, the result path, and the output path. And we're going to look at how you can use the data flow simulator to kind of simulate and model and sort of examine your JSON structure, JSON paths, to help you understand how that state is passing through each one of your workflow steps. And we're going to build out a live workflow and see how we can use that as we're building. So without further ado, I'm just going to switch straight in to a little very simple workflow that we're going to start building. Now, this is a SAM template. SAM is our infrastructure as code serverless application model.
Sorry, Ben, can I interrupt
Go ahead,
you?
Julian.
As usual, ask for a font size update for the
a font size in
for the people with the weak eyes in the back.
How's that? Is that better? More?
If you can read it, I think we're okay. We can always go bigger.
We'll do our best. Okay. So this is a SAM template which lays out just two cloud resources. One is the workflow that we're going to build, and the other is a very simple Lambda function. And then here we have the output ARN of that workflow. Then over here is where we're going to build the definition of our step function workflow, okay, in JSON. So the first thing we're going to do is use the AWS, what's the official name for it, Julian? The tool for
AWS
Studio
Toolkit or Visual Studio Code.
Lovely, thank you. So this knows that I'm about to build a step function because it's called asl.json. So if I press Control Space, I get a few options about how I might want to start building my workflow. So I'm going to say start at, and I'm going to create my first state. I'm going to call it prep. And then I'm going to use the control and space again, and I'm going to say, let's start building some states. So the first state I'm going to build is going to be, so that's control space again. And here it gives me a list of different options of different types of states and types of tasks I can now use and kind of throw a templated version of that straight into my definition here. So I'm going to use a very simple type, which is called a pass state. I'm going to strip this right back. Keep it really simple. I'm going to name it prep. And I'm even going to take this out, and I'm just going to make this the end, capital E, and quotes matter, so end equals true. And here we go. That's automatically rendered on the other screen here. This is like a very trivial, super simple version of a workflow.
So this is one of the coolest bits I like about step functions is, even though step functions can be hugely complex in the workflow and automation they can do, you've always got this visual way to look at it and be able to reason. I'm a more visual person than a written person, and so this is just simply looking at start, prep, and end. But you'll see as we get later that can get a bit more complicated. But it's really nice from step functions to be able to see visually what your workflow is going to be.
The step functions team are actually really good at helping you to visualize your workflow in lots of different ways, in the console, in your IDE. With this data flow simulation tool, they're constantly coming up with better ways for you to build workflows with writing less and less code, right? So that's a great thing that the PM team is doing. I'm not just saying that because Dan's on the call.
Thanks, Dan.
So, yeah, cheers, Dan. Right, so let's have a look at what I just built, right? This is here. I'm gonna have a look at the definition. See, we've uploaded that to the cloud. I did that whilst Julian was talking there, a little deploy. Super simple pass state workflow. So what I'm going to do is I'm going to just run this now with a bit of test data. And I'll show you the test data that I'm going to put into it. So this is a kind of very small example of what might be a store or a basket checkout, where we have a bunch of books in an array. We have the category, the author, the title, and the price of those books. And then we have a different type down here. We have a bike. Really simple data set just to help illustrate what we're going to do. So I'm going to paste that. Oh, go back one. I'll take that example data. I'm going to put it into here. And I'm going to start my execution. And we're not going to see anything too fancy here, but what I want to show you is the old way of kind of, or the way before this new tool was built, of looking at how a payload is kind of passed into and out of our task state. So I would click on my pass state here. I would look at the input, and it's exactly as I expect. It's what I just pasted in. And the output is exactly as I expected as well, because I haven't set any of my special controls to manipulate that JSON data. I've simply passed it straight through. Okay, let's build out something else to our workflow now to actually show this doing something a bit more useful. So I'm going to use a Lambda function for this. I'm going to go back to my states, which is just going to very quickly control space, do a Lambda task state. I'm going to get rid of it. Oh, I'm going to get rid of this bit here. And I'm going to go to my YAML template, and this is what I need to add. This holds the arm of my Lambda function. So I'm going to paste that into here, I believe with curly brackets. This will be the new end. True, and then next, I'm going to call this sum. Let's have a look. We'll go for fiction books, and this will all become clear in just a moment. So here we go. That's going to be that. So this should render straight away. There we go. So this is what my new workflow will look like. I'm going to go ahead and deploy that. And then what will happen is when I go back into the step functions console, I'll see that that has been deployed. Now, what I would have done before this tool, Data Flow Simulator, was built is I would have used something like this, a JSON path online evaluator. And I would have, if I wanted to evaluate a certain JSON path, I would come in here. $sign we know represents the entire JSON payload. And I would have examined this by trying out different JSON paths, saying $store.book. And that would, evaluate and be quite useful for me to find out how I can grab certain path syntax to put into my step functions workflow. And this was okay, but this doesn't help me in the context of my actual task state. I don't know what this looks like at different points in my life cycle. I can just grab, evaluate one specific path. So what this looks like now is something very different. If I go back to my step function.
Sorry, Ben, can we just jump to the JSON path simulator? I know there's not much to see there, but we can just zoom in for a bit because people are wanting to just see what that's about.
I haven't shown you it yet.
Haha.
So this is an online website for just evaluating JSON path in general, just some open source website, jasonpath.com. This is what you might have used before we built the JSON path simulator, right? Just to get an idea, a little bit of a helping hand onto how to build or how to create a JSON path based on your payload. Now I'm going to show you a better way of doing it. So first of all, I'm just going to make sure that that's finished uploading. Check it's there. Here we go, is my new Lambda function. And I'll go and kick off a new execution. I need to paste my payload back in. Okay. So you'll notice that my Lambda function task state has actually failed. And so what I would normally do is I'm trying to debug this. I would see what the input was to my first state. Yeah, that's exactly as I expect. The output of that is as I expect too, because I haven't done any manipulation on it. Then I click on the next state and I see what the input is to this. And it's the same as the output from my prep state. Okay, that makes sense. There's no output. Okay, that makes sense because it failed. I'll click on the exception and see what that was. And it says it cannot read property book of undefined, and it's given me an error on line 6 of my my Lambda function. So let's have a look at my Lambda function. If I look on line 6, it's saying it cannot read a property book of undefined. So that suggests to me that store is undefined, right? If I just flip back quickly to my step input, it looks from this way of evaluating the payload that there should be something called store in there. So something's going on with my step function and my input payload that's difficult to debug at this point, right? So this is where I can jump over. I'm going to copy this and jump over to the data flow simulator finally. This is the data flow simulator. So here you can see that across the top bar here, I have links to each one of the data input controls for my input-output path processing. Remember, this input, parameters, result, they're all mapped in the order that they are applied across the top here. the first thing I can do is I can paste in the actual payload that I know my state receives as its input. So I know I've just copied this from the console. I know that's going to be the actual state that it receives. I'll tab over to the next point. So this is the first point at which I can try out different path expressions. So normally in here, I would just have a play around, right? I would try out store, just like as I was doing with the online tool just now. And I can see it immediately updates on the right here based on this path that I've got here. But I know that I don't have an input path specified in my my task state. If I go over here, you see there's no input path for this state. So the default, the default would be just this. I know that that's exactly mapped now to what my my task state is doing. If I go next, I can see the next thing that's applied is the parameters. And if I go back to my definition, when I added this using the IDE tool, it automatically added some parameters for me, which perhaps I don't want, right? That wasn't apparently obvious just by stepping through the console. So if I remove them, I keep going to the wrong side there. If I remove them and scroll down, I can see, okay, this is exactly what will be now sent to my Lambda function. This is something that wasn't revealed in the old way of stepping through, but it now marries up exactly to the definition that I have that I've created in my IDE. So I should be okay to go ahead and deploy that now. And that should now run correctly because I can reliably know exactly the payload data that is sent specifically to my Lambda function, right? I go back.
Yeah, and that's super helpful. So this is immediately you've got a troubleshooting step. Something's a bit strange. You think you've got the data you want, and this is just an integrated JSON path editor right within the step functions console. And as you were literally typing there, the outputs was being sort of brought up before your eyes. Makes it super easy to work out what's going on.
Exactly. Yeah. So that's deployed. I should be able to just run a new execution here, and we should see this work straight away. We do. So now I can step through again in the console just to confirm the input that was given is expected. The output, now this is coming from my Lambda function. It's returning the output from my Lambda function, and we'll show you in a minute how you can manipulate this output as well. So one of the best things about step functions is that it really helps you to reduce code in your Lambda function. And reducing code is always a good thing because there's less for you to maintain. There's less risk of using third-party libraries and patching and security. So reducing code at any point is normally a good thing, right?
Especially with the code I write.
Especially with your code, yeah.
Absolutely.
You said it first.
Want it as little as possible.
So there's a few things we can do here, right? One of the things I've got going on here is not very efficient. And that's that I'm looping through every single book that is, or in fact, every single object that's provided to find a book of category fiction. It would be better if I could manage the payload that was sent to my Lambda function and just make sure that I send it fiction books, right? And I can do that, and I can evaluate how to do that with the tool again, right? So if I go back to my input path, remember this bit here. Okay, so I want to make this state input after input path, the result, to show just fiction books. And I can use something called JSON, a JSON path query, right? Or I think I can. Let me try. I think it's something like this. I'm going to go store dot book. I've actually forgotten how to do it. And I think you do this to show that you're going to do a query, and then you do an at, and then you put in the field that I'm going to query, which is category. Oh, okay. I'm going to go equals. It's this one, isn't it? Category. This is what I'm evaluating. Category equals fiction. Close that off. Something's wrong with that. Maybe it's that. No, store.book.
Just if you are stuck, there is a link to a JSON path expression link just above that. I know you're going to work it out, but yeah, for us normal people who don't just write JSON paths off the top of our head, there's some help above that. Yeah,
I mean, darn. Let me try and figure this out.
It's like one of these cookery shows where it went into the oven and didn't come out quite as you expected. But
no, this is exactly as you're doing it, right? So if I do store, I know these are all the stores, and I think I want store. I want all the books. Oh, maybe it's here. Maybe it's here. Category. I thought it would be dot book. Store dot book. Is it this? No. Damn you.
Anyway, we are expecting to get the filter of all just the fiction books, correct? Is that what the
hang on.
we are aiming for? We're there.
Yeah, we're expecting to get all the fictions, but we've got to get this working because this is what our input path is all about, right? It's about evaluating the right expression.
So if you didn't also have this data flow simulator, you could be trying this 100 times in a Lambda function, firing it off, and I mean that would be the really clunky way to actually test this. Or you could be using some web-based service to do that.
Let's try a few other things. We were going to look for anything with a price over £8. There's something wrong with the way I've done this bit. Oh, there must be some JSON path. I know what we can do. We can look at the blog post that has a very similar thing.
Who wrote that blog post? Yeah, Piperman is saying book is an array. Is that catching you out?
Maybe, yeah, something like that, isn't it?
Fat Daddy 606 suggesting ticks around fiction.
No, it's not that. That's a good guess, but I remember it's not that. Let's go here. Look, this is the blog post all about it. There's a very similar example in here somewhere. We're down here. Look
One has a suggestion.
Oh, maybe it's this. Look, maybe it's this. What's one suggestion? I'm keen. Give me your suggestions.
We'll get there.
You didn't like that. Okay, so we do that. And we do that. Yay! Here we go.
Excellent. Right. So we're crowdsourcing JSON path things. Thank you for sending them all.
Thanks everyone. Right. So now what I have is I've managed to filter eventually just all the fiction books. So what I'll do now is I need to apply that to my step function, right? So I'll flip back to my step function code in my definition, and it was the input path, right? And I can just put in exactly what I just made there. So now I know reliably that my Lambda function will only receive an array of fiction books. So what that means is I can take this whole if statement out of my Lambda function. I can do better than that though. In theory, right? I should be able to do better than that. Because if you notice in my Lambda function, all I'm actually using is the price of the book. So I can reduce my payload even more, right? Step functions can handle 256 KB payload. So I should try and reduce that wherever possible and throw away the data that I don't need for, when I'm passing it to my downstream service. So I'm going to do that in the next bit in the parameters section. If I tab along, so I know that my parameters section will receive an array of fiction books. So here I can build up a key value pairing of parameters to provide to my service integration, to my Lambda function. So I'm going to try and remember how to do this. So what I'm going to do, I'm going to have something called fiction book array, for example. And I'm going to explain what a dot notation means in just a second. And I think here I want anything that dot price. Not that. Oh, I forgot my $sign, didn't I? There we go. Now I've created an array called fiction book array. And all it's done is just smashed all those prices together in an array, because that's all I really need in my Lambda function, right? So again, I can take that and I can put that into my definition over here. That was the parameters, wasn't it? The parameters. Let's do this proper way. Let's do this the nice way. Parameters. Okay. now that I've done that, I need to change a little bit my Lambda function. Let's go into my Lambda function. It's not going to be event.store.book anymore. It's going to be event.fictionArray, and then that's just going to be the price, right? Because when it iterates through, it just has each price. So that should work in theory, unless I've missed something. It's highly likely. So what I've done there is.
Sorry, I just was talking about the use cases for this. You've obviously tried to strip out information as it's going through the paths. So the step function's next part in the state is going to get less information. Obviously useful if you're bumping up against any limits or that kind of thing. But also some of those use cases could be redacting personal information. Maybe you've got a credit card number, or you've got some customer name that's going to a third-party service or something like that. And so you could use these this parameter option to be able to remove whatever you need from your different as it passes through your different states.
Exactly, yeah. So we've done a few things. We have managed our payload size and our actual payload construction. We've reorganized our payload. We've added some parameters so make it easier to access in our Lambda function. And we've managed to reduce a whole bunch of logic in our Lambda function as well. So imagine this was a huge array of books, of hundreds or thousands of books that you were passing through of all sorts of different categories. We've cut out about 90%, probably more actually, of our payload just by applying some simple JSON path routes there, right? It's all about sort of cleanliness of your payload, really. So we can try that. Let's give it a go, see if it works.
We have a fan already. We've got Doug Toppin. The Dataflow Simulator will save you time, whether learning or during development. It's great for experimentation. Thank you, Doug. I'm glad you're seeing the light of the Dataflow Simulator.
Doug knows what's up. So look, that worked. That's nice. We can do more, though. We can do a lot more with this. Do we have enough time to show some more stuff?
Yeah, let's go for it, yeah.
Let's show some more stuff. So another thing you can do, or that you would be aware of when you're building a step function, is that you can kind of append or reduce or overwrite your payload at different parts of your task lifecycle. I'll show you what I mean, right? So let's say here, my Lambda function, sometimes it got an error. I wanted to catch that error. Well, I can use the built-in catch mechanism of step functions, not that one, this one. This one? I keep using the wrong one there. This one gets me a little bit further along. Okay, so this will say now that if I get an error, any sort of error, I'm going to handle that error in a new state. So I'm going to write that new state. Where am I at? My font is so big, it's very difficult to see where I am. Actually, that will still be end. And then we will have another one called, another one. We'll just make this a pass state or a fail state for now. How about that? We'll call it manage fail. This is what we'll go to if my Lambda function fails. And then there we go. And then that could be end true. Why doesn't it like that? 26. Oh, why doesn't it like that end true, Julian? Oh, is it because it doesn't like commas?
Capital E and D.
I know what we'll do. We'll just use the old end true. There must be something higher up. Ah, here we go. That needs comma.
Comma, yeah.
Commas always get you, don't they? Right. So what this will do now, if I were to run this and we got an error in our Lambda function, this manage failure is the state that will maybe send downstream to a different Lambda function or add to a database or an SNS topic to remember this error that I had that I can then handle later on. It will only receive the actual error message. It won't receive the original input payload, which might be useful when I want to examine this at a different point, right? And this is a way we can use our path processing to, as well as just sending the error, we can also send the original payload along with it. And the way we can do that is we can add something here. It'll be the result path. We can check this. I'll keep going to the wrong one there. Come on. So if I go back to my my Dataflow simulator, here I am allowed to put in the task result of my Lambda function, right? So I might as well go ahead and do that. This is what my Lambda function is currently returning. I'm going to paste that into here, and now I can go ahead and model some JSON paths to handle that. I'm not going to use the result selector for this particular example, so I'm just going to leave that blank and go ahead to the next one. Here, the task result, right? So this is something that can be really useful. If I set a result path, what it means is that I can retain the original input to the state before anything was applied, and I can hold the Lambda function task result in something called task result. And that way I'm appending that to the output of my, my state. So I'm going to go ahead and do that. I'm going to apply that back to my definition here. Do that anywhere. Oh. Got to give it the name, result path.
So this looks like a really slick way where you don't have to pass all the information through all the steps and then sort of combine them at the end. You can sort of grab information that's happened earlier on in the state machine and append it at multiple various stages, and not have to, I suppose, manually move the data around or keep state of the data within Lambda functions or within even the state machine itself. And you can just reference it in the last step or whichever step you need.
Yeah, exactly. And similarly, in my catch statement, I can pass in a result path that will hold the error as well. So what this will mean is my manage fail state will have both the failure message passed to it and the error message passed to it, so that my downstream service can manage both. They might both be useful, right? And we can see, oh God, I keep going the wrong way. We can see what that looks like here. If I go back to my step function and run that, you should see it update. Although the problem is that didn't fail because there's no error in my Lambda function because my code is so good. So let's make it fail. I'll put a syntax error in there. Trivial fail, but we just want to show how it works, right?
Yeah, just showing in the background while these builds are happening, you can actually see how quite quick it is. Ben's using AWS SAM, our infrastructure as code tool, to do a whole build and deploy between each step. And you can see it's actually pretty quick to get all the details up and going. And specifically when you're also not wasting any time by doing all this in-part stuff, which you can do in the console, you're not having to update your Lambda functions and your state machines as often as you maybe would before by testing all these different scenarios.
So here we go. I have a nice visual representation of my error. I've got to my fail state, and we'll have a look at the input that comes here, right? We have the original input to my entire step function here. And then also we have the error that was caught by this Lambda function. That's because I've added that in my as a result path to the catch statement. So what that means is that I'm able to now handle my errors along with the input payload that caused the original error. Much more useful way of dealing with errors in some situations. So I'll pause there. I'm sure there's plenty of questions. Should we go to some questions?
Yes,
Get Dan back involved.
Yeah, thank you very much. I'd like to just jump. One of the earlier questions much earlier in the show was talking about the payload limit, and Step Function's payload is currently limited to 256K. And there was talk about, well, what do you then do if you need to exceed that? And obviously you've talked about some code reduction techniques over here, but if something's bigger, should we use S3? I'm happy to also bring Dan in. Dan, what would your recommendations be if people are starting to bump up against Step Function's payload limits?
Mm-hmm. Yeah, so definitely I would recommend a lot of filtering. So great demo of the data flow simulator, and definitely would recommend if you're going to up those limits, use a lot of filtering. What a lot of customers also do is use S3 and store the data there and pass the path through the workflow into the Lambda function or whatever is going to be accessing it. And so yeah, those are the two of the options.
Okay, thanks. Yeah, a lot of comments about the AWS toolkit for Visual Studio Code, and wondering why isn't it in all the in all the toolkits? Well, we've got Dan here. We will knock on his door and any of the other product managers for the developer tools. But yeah, at the moment, the functionality is only available for Visual Studio, the AWS toolkit for Visual Studio Code. But I'm sure with enough interest, we would love to be able to extend that to some other products, please. So yeah, people have been talking about PyCharm and various other kind of things. That is the state. So yeah, just a question about state machine fails. Does the specific error get propagated, or do you only get states.failed? I don't know if that's got enough context for either of you to answer that.
I'm not sure. Does it get propagated? I'm not sure what that means.
So,
okay.
So perhaps the question is, I guess if you have a if you invoke a state machine and you're in one, so I assume that's a nested state machine invocation, and then that nested state machine fails. Does the specific error message get propagated up to the parent state machine, or you only get states.failed? I believe the answer to that one is that you would only get states.failed. However, I'm not 100% sure on that, so some others could feel to chime in if.
Okay, one. Yeah, thanks for that. And then just going back, there was a couple of questions and comments going back and forth about the reusability of Lambda code, and have to do filtering in code or doing it in various kind of things. And yeah, just Halamiho, you've had a few comments which have been super useful to help other people also understand the filterings. And then somebody said, well, Alpa Code said, well, we're not reducing the code that much. We're simply converting JavaScript into DSK, but that was said obviously DSL. But there's a lot of commentary about it's when you have map and parallel states, and the filtering with step functions would be beneficial for this. So yeah, I think it obviously depends. You can have this could very likely introduce some more reusable Lambda functions where you're not having to do a whole bunch of filtering. And if, for example, if you are selecting on price in one Lambda function for books and then price on another Lambda function for movies, well, you could potentially have a single Lambda function that could do price on whatever it receives and do the filtering in the step functions state machine. Let's see. I'm just trying to grab some pictures, grab some more questions because we have a lot on the one kind of things. Let's talk about X-ray a bit. At this stage, I'm correct, Dan, that Step Functions Express workflow does not support X-ray, but standard workflows do.
Actually, no. Express Workflows does fully support X-ray.
Oh, there we go. Excellent.
Express does have some more limitations, such as, so I know some commentary about the visualization. And so I guess I'll just provide some clarity on that. So when you're working with Express Workflows, I mean, you build it just like any other state machine, so you can visualize as you build. You can also use the data flow simulator and as you're crafting your Express Workflow, because it uses the same Amazon States language syntax. Where you do miss the visualization is at runtime, because what happens when you run with Express is it does kind of dump the execution history into CloudWatch logs, and so that's where you need to retrieve it.
Okay, Dan, just quickly to jump in for people who may not be aware, what is the difference between standard and Express workflows?
Yeah, so great question. So we started the service with standard workflows, and what standard provides is like checkpointing throughout the workflow. So it guarantees once and only once kind of execution of each step through the workflow. Where we introduced Express Workflows to help cut down on the costs, so that's kind of like for like data processing. The way I kind of think about it is like control plane versus like data plane. So standard workflows is kind of like your control plane, and if you want to be running a lot of workflows in parallel or doing a lot of things really fast, or say build an API that's back-ended by a workflow like that, those are all great use cases for Express Workflows. They run for up to 5 minutes, really fast, can run at tremendous scale. And so basically somewhat use cases, but you can nest them and kind of compose them together so that you have like a standard workflow calling Express Workflows, say perhaps with a map state. So.
Thanks. Alpaca is just asking, Express workflows, does it automatically mean it's synchronous?
So when we first launched Express, it wasn't synchronous. So by default, it's not synchronous. And if you need to call it synchronously for it to be synchronous.
Can I something that we see developers doing as well? Yeah, just earlier on, someone was talking about the developer experience in the console when you're building out standard versus Express. What we see people doing is building a workflow as a standard workflow as they are sort of debugging and understanding it, because it's easier to kind of step through the different task states, and then simply copying and pasting that definition and changing the type as an Express workflow, because that's how it is supposed to run in production. So that's a nice way of like getting the benefit of the builder experience of standard, and then the running experience of the Express type.
Excellent. See, one other thing I just wanted to get your thoughts on is that a lot of the focus on serverless development naturally comes to Lambda, because it's a compute service. It's where sort of business logic and things happen. But something I'm hearing more people understand is actually often is to think of your business application, which is often a bunch of workflows, and is to actually often start at thinking about it in a step functions way, and only start introducing Lambda functions when you need to. Because as you can see, even from the demos today, there's a lot of transformation that can be done natively within step functions, and starting off by developing a whole bunch of Lambda functions may actually not be needed. So yeah, Dan and Ben, how do you think about starting off with step functions, or how to find some use cases, or what kind of business processes are people thinking about that they should have step functions top of mind?
Yeah. So yeah, if you're starting with step functions, we have a lot of customers. At least the mental model I use when I'm kind of breaking down the use cases for step functions is basically like there's four different primary categories. So this is where a lot of people started, was like IT automation, and so kind of lumped in there. There's like some customers use step functions for managing their deployments and kind of CI/CD. I mean, any task that you want to automate, kind of use step functions as an automation engine. That's a great use case. We also support, we have a data science SDK. We integrate with SageMaker. We support like AI ML type workflows, and you can. So we support a lot of the SageMaker APIs, and if you want to kind of use other services like Textract, you would write a Lambda function to call those. So any sort of like ML ops type use case. Another one is if you're building like serverless applications. So what really distinguishes us as a workflow tool is the ability, kind of like, you can have an event that invokes a workflow, and kind of how well we work with like Lambda. And so kind of as part of building like event-driven applications. And the other area is like data processing. So a lot of that's actually probably the use case customers use us for the most, is kind of orchestrating data processing jobs. So that can be like simple kick off a workflow when I get an event from like an IoT device or something like that, everything through to like, I want to process a fair bit of data in parallel, and by like slicing it up and processing it on Lambda or through containers. So yeah, like store checkout process, all sorts of different things can be automated through step functions.
Thanks, Don. Thanks, Dan. Ben, anything else to add on that?
Yeah, I actually think step functions is a really good use case, even for things like website backends. So anything that needs to be triggered by some sort of event happening, where a sequence of things need to then occur based on that. And that sequence of things is based on conditional logic, or has to be repeated with loops. It's great to use step functions to take all of your kind of conditional branching out of your Lambda functions, and just use very sort of small, discrete, secure Lambda functions just to run individual pieces of business logic. And when you build step functions that way, and you start to use them for things like error handling for your Lambda functions as well, the use cases sort of, they grow and they grow. And it's such a nice way of building as well, such an enjoyable way of building an application too. So really anything that is event-based, that needs more than one discrete piece of business logic to happen, step functions is worth considering if it should be used.
And then I suppose people can also take the benefit of having an asynchronous workflow on the back end and then a synchronous workflow on the front end. So people are going to hit an API and they're going to upload something, or they're going to send some bit of information. And then you don't necessarily have to have that step function waiting to provide that information to the front end, but you can use WebSockets or IoT Core or something like that to update the front end eventually. But yeah, there's always a whole bunch of back end work going on to combine stuff, to move stuff around, to call out to other services.
Well, yeah, and with the synchronous express workflows, you can reasonably use step functions for near real time experience of some sort of back end data processing being then returned to your web front end. And there's a nice blog post that came out with the release of synchronous express workflows that shows an example of that.
Excellent. What are sort of some recent integrations with step functions that people may find useful? Further integrations. I know we've had one or two comments about, for example, when would S3's mentioned a few times, any plans on step functions service integration to get put data to from S3 buckets. I'm sure Dan is sitting with the whole next few years of step functions releases on his desk, and he's dying to tell everybody about it. But what kind of things? Two-part question, I suppose. What kind of integrations have come out recently from step functions that are useful and worth highlighting? And yeah, is there any kind of things to think about for the future?
Mm-hmm. Yeah. So great question. And I'm sitting here as the PM with a lot of things that I want to say that I can't talk about. So my hands are kind of tied. But I will say we're working on a lot of interesting things this year. But yeah, some of the recent service integrations are like, so we integrated with Athena, and interestingly enough, a lot of customers are using that for managing kind of like billing data, etc. And code build is another like service integration that we launched last year, and EKS. So we supported ECS containers through ECS, but we launched a pretty like fully featured EKS integration, which you can use to like both like submit work and kind of manage your cluster. Yeah, so those are some of the recent new services integrations that we've launched that customers are finding quite helpful.
Dan, what's the best way for customers and developers to request new stuff from you and the team?
Yeah, so if you have an account, like a technical account manager where you work, like probably one of the best ways is if you have a really kind of a more detailed request, you can submit it through your account manager, and they will file what's called a product feature request, and that's a great way. That's a great way to get features into us. So we look at those very regularly. Another is if you have requests through some of like the open source tooling, like the Data Science SDK, like Visual Studio Code, the AWS toolkit for Visual Studio Code. If you file kind of GitHub issues against those, that's something else that we take a look at. Twitter as well. So I'm pretty active on Twitter, always looking at new requests for step functions. So if you put something on Twitter and you tag it with step functions, pretty good chance I'm going to see it, and one of the PMs is going to see it and take a look at it.
Excellent. Thanks, Dan. Another thing I was thinking about as well is often people are building applications, and some of it may be serverless, some may not be serverless, some may be a mix and match of the kind of two. And like you mentioned EKS and ECS, I can also see step functions as being super useful to use the sort of best breed of technology that you can. If you have some container tasks, or you have some things that need a port and socket model, and you want to do something behind an API that's and you want to also use Lambda functions, step functions are a really good thing to look at to be able to glue these disparate parts together, maybe using very different technology.
Oh, absolutely. Yeah, you can kind of use best of breed for compute services through a workflow, right? So we have a lot of customers that will say combine together Lambda and batch, sometimes choose between Lambda and ECS Fargate for containers, depending on the length of the task. You can use step functions to orchestrate like on-premise compute or compute that's running on EC2 through the callback pattern. So yeah, there's a lot of different people are using combining together different compute into a single workflow to kind of choose whatever one serves the purpose best for whatever they want to do.
Thanks. That was one of the next things I was going to ask is about that callback pattern, because Ben mentioned in the beginning step functions can run for up to a year, which sounds crazy, but also you can have human interaction with step functions. Sorry, we don't have buttons in an AWS data center that a human goes and runs into push for the step function to continue, but can you just quickly say how the callback pattern would work for something like step functions and how manual processes can be incorporated?
Mm-hmm. Yeah, so I've actually been meaning to like build a manual button that I have somewhere in my house that controls a workflow. But you can, as long as you, so you can, and you can use like SQS. Like this is a way that people implement like worker queues or etc. Is that you can take a task token, send it out as a request on an SQS, and pass it through some compute. And when the callback is made, there's a send task success API, and when that call is made back to step functions, then the workflow will continue. So you can use that for kind of human interactions, a lot of like business process type use case, or like approvals as well. So you could have like an email based approval that would go out, and when the user clicks on the approve button, the callback token will come back and the workflow will continue.
I've posted an example of that, Dan, human approval in the chat here. We're automating a security incident, which is exactly that.
Fantastic.
That example.
Thanks. Just one question from Alpa Codes before we do need to wrap up. Any serverless scenario where step functions is not appropriate? I'm glad you can't think of any, but yeah, anything that people may bump up against anything? We're all scratching our heads.
No, I can think of one. So there's often examples of where maybe event bridge and step functions might overlap, where they could both be used to solve similar problem. So yeah, it definitely might be worth considering your use case if it's more of a kind of an event bus based use case. What is it? Orchestration versus choreography is the common term that's used. So use step functions for orchestration and maybe use event bridge for choreography. That's all I can really think of. Is there's a lot of intersection between those two.
Thanks. Well, that's unfortunately all the time we've got for today. Thanks so much for all your questions and for the about 30 comments all helping Ben with his code. I'm glad it wasn't me coding live because I would have even got it more messed up. So yeah, really appreciate you helping out. Thanks so much for Dan for joining us as the Step Functions product manager and helping us with the questions. And yeah, just to talk about what's coming up next week, we've got API Gateway coming up next week. And that's going to be some also awesome new stuff that Eric Johnson is going to be talking about with the host of James Bezic. And then just if you aren't aware, there's got a whole rota of serverless land that comes along. This week is step functions. Next week, I said, is API Gateway. And then we circle through messaging and events, serverless surprise, which is going to have Rick Houlihan, the expert 400 master level on DynamoDB. Messaging events, we'll be talking about Kinesis. And then we're on to Lambda over the cycle. So this cycle goes on same time, same place every single week. So yeah, we really appreciate you joining us here today. And thanks so much. Of course, please look at serverlessland.com. And this has got events, learning paths, serverless patterns, all the blogs, all the videos, everything that happens to do with serverless on AWS. And so thank you so much for joining us. We really appreciate you spending your time with us today. And happy building on serverless.
Cool. Bye-bye.